Okay, good afternoon, good evening, good morning, wherever you are listening to us. We are welcome to this class. Today, vector and tensor analysis. And today we'll be talking about the surface integral, and we'll look at the application, and then we'll move to volume integral along the line. Permit me to share my screen. So here we are now. Can you see my screen, please?
Yes, sir.
Thank you. Okay, surface integral. Under the surface integral, there are a lot they can ask you to get from the surface integral. We can ask to calculate surface normal. They can say surface areas, surface integral of vector field. But you have to read the question before you answer them. You have to know the mindset. When I say surface, in this case, is talking about the vector V or R. Let me just use this one. U comma V, which is the same thing as X of U comma V, Y of U comma V, and Z of U comma V. They are all belongs to U comma V. This U comma V belongs to D and contained in the R space 2. This is for surface. But when you have the area, or normal rather, how do we write the normal? So for normal, they can ask you to calculate the normal of it. Normal is this. U of this normal cross of V, RV. Then they can also ask you to calculate the surface area. Which is represented by A, which is integral of this, D, then absolute value of the normal, dU, dV. Then you have surface integral of a scalar function of scalar function is going to be integral. Remember, surface is double integral of f dx, which is the same thing as integral d of f over x uv, comma, y u comma v, comma z u comma v. Everything multiplied by normal. Don't forget du dv. It's all together, please. Because of the space, that's why I just jumped here. You can also ask us to look into surface integral of vector field. Vector field. For the vector field, we're talking about integral s v dot dx equals to integral d f dot normal du dv, which is the same thing as integral d p dy dz partial derivative du comma v plus q d dz dx over du comma v plus r dx dy comma v du dv. Sorry. So it's the same thing as when you have integral x p dy dz plus q dz dx plus r dx dy. So let's take note of that. So for us to solve this now, there are certain things we need to check. Let's look at the example. Are we there, please?
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
Okay. Example 1. Evaluate integral a dot n dx, where a is equals to z I plus xj plus z minus 3y squared z k. And S is the surface. So when you see question like this, they're talking about surface integral. And S is the surface. If S is the surface, what next do we need to do? S is the surface of the cylinder. S squared plus Y squared equals to 16. Included in the first octant between Z equals to 0 and Z equals to 5. Z equals to 0 and Z equals to 5. So how do we solve this problem? There are a lot of things that are involved in this case, which means we need to solve this. It's necessary we have a diagram. If you can draw the one, it is better you draw. If you cannot draw, you can also manage to solve the problem. Okay, let's look at the solution. For solution now that we have this, part of the formula that I'm supposed to write, x a dot n dx is the same thing as when you take it to plane R, you have it to be a dot n dx dz over, remember its magnitude value of n. So the magnitude value of n that we're talking about here is still the same thing as the one we have initially. But in this case now, note that the projection of x is on xy plane cannot be used here. Because xy plane cannot be used, then we use z. If you have time and you plot the, let me just see whether I can give you a little diagram here. So we have the z here in this case now. X is here, then the y is here, the z is here. But don't forget, like I told you, so at this point is the origin. So somewhere here we have our R, and somewhere here we have the X, then we have the survey, we have this particular point that we are working on. So in this case now, our N will be from here. Let's say N, we have our N in this case. Then at the angle of this, we have the X. So, but why I'm saying this is, if you look at this point, this is the point we are talking about Z. Our Z equals to 5 here. Z equals to 5 in this point. And if you look downward, at this point now, we can Z, our Z at origin equals to z equals to 0 in this point. So it's a complicated example whereby if you don't know what you are doing, in some cases, you might eventually miss it out. But nevertheless, all I want you to get the idea is, let us represent this. Let's see how we can represent this mathematically. So now that we have the formula, the solution, and I've told you that in this case now, a normal, let's look at this, a normal to x squared plus y squared equals to 16. And don't forget the del of x squared plus y squared is equals to, when you differentiate, you remember the del means differentiation, partial derivative. You differentiate. When you differentiate this one, you have 2xi plus 2yi. So thus, the unit normal to x, thus the unit normal to x as shown in this particular figure that I tried to depict from here by adjoining each other. But remember, when you have to calculate this, what do you have? When you are finding magnitude value of n, which is the normal, you still remember, who can tell us how to find the magnitude value? Anybody, please? I'm waiting, please.
It's going to be equal to the square root of the value given.
Yeah, you first of all do it this way. That's 2xi plus 2yj divided by square root of what?
Of 2 square plus 2 square.
Of 2, is it 2x squared or 2 squared?
No, 2 square.
2 squared plus 2 squared.
Plus 2 square, yes.
So at the end of the day, you have x I plus yj over what? Over 4. Am I right? Because 2 square is that, this is 14, right? This is 16. Am I right?
Yes, sir. The answer is 4, sir.
Yes, the answer is 4. Good. So, but that's not the case where we are going. We only calculated the n. Remember the formula said dot j, so we've not got to that place. This is the clearance off the line from Nico Williams. Forward the shot, it beat Navas. Nico Williams. If you are watching your football, please watch alone. Please don't confuse us. Yeah. So we can go ahead and say that, okay, A dot n will be what? Remember your n, A. Your A is what, please? Our A is Z.
S square.
Zi.
Okay, yeah.
Plus Sj minus 3y squared Z. Dot x squared dot xi plus yj over 4. Am I right?
Yes, sir.
So I to I, j to j, k to k. You still remember? So we have here, we have xz plus y plus what? xy. Do you agree?
Yes, sir.
Everything over 4. Which is the same thing as 1 all over 4 in bracket xz plus xy. So what about when we calculate n dot j? What do we have? Remember, you have it to be xi plus yj over 4 dot j. So at the end of the day, you have it to be what? Y over 4. Do you agree with me? Hello? Hello?
Yes, we are with you, sir.
Do you agree?
Yes, sir.
Okay. Now, the question is, we need to go back to the formula to be able to solve the problem. Remember, the formula says what? This is the formula. We just calculated n dot j. We calculated a dot n. So absolute value, magnitude value of this, we've done that. We've done this. Remains to us to do x, the x, the z. So let's substitute. It's very simple. We can now substitute it back to the service. So then the service integral equals integral of r xz plus xy over y ds dz. Do you agree? Are we all there together, please?
Yes, sir.
We are together, sir.
So, who can tell us what to do next, please?
We differentiate x.
Differentiate where? Yes, we need x now.
Yeah.
We need x. We have y already. We have z already. Our z, we need the limit now. For limit or for boundary, for limit, let's use bound limit. Z is equals to 0 and 5. And z equals to 5. This is lower limit, this is upper limit. So for us to get for x now, because you have to integral. So remember, you have x squared plus y squared equals to 16. Now I need my x. No, if you want to get, sorry, you need y rather. Remember, you need the value for y inside this place. I can now look for y. How do I get that? I can now say that y squared equals to 16 minus s squared. Then y is equals to square root of 16 minus x squared. Now go back to the equation, to this one. So anywhere you see y, you substitute this there. This is the value you need to substitute anywhere you see y. Please take note of that. So, which means I have integral of 0, let's say z equals to 0 to 5. Then z equals to what? X equals to 0 to 4. So how do I get 0 to 4? Who can tell us? I can see it where I just calculated now. When you put x to be equals to 0, what is the square root of 16? 4. Are we together?
Yes, sir. So we didn't get the question again, sir.
Now, we can substitute this one. Let's go to this one. Xz over y plus xy over y. Everything is the s, the z. But don't forget, it's the same thing as integral of 0 to z equals to 0 to 5, integral of s equals to 0 to 4, which means this go with this. So I have xz over square root of 16 minus x squared plus x ds dz. So I can go ahead and integrate them one after the other. If I want to integrate, let me integrate x first. If I integrate x first, what do I have? Anybody, please? Somebody should help us. I want to integrate x first. What do I get? I'm waiting.
Good.
Anybody?
No idea, sir.
Which one is no idea? Will you tell the now no idea on the 9 or on the what?
So I want to understand what the question is about. We're integrating the whole of this.
Yeah, you are integrating it.
Okay.
But remember, you have double integral. The first thing is you integrate with respect to x first.
Yes. Okay.
The second time is you integrate with respect to z.
Okay. With respect to x, we're going to have the numerator is going to be x to the power of 2.
Remember the square root.
Is divided by oh shit.
Then upper limit minus lower limit. Anyway, what I will do is you guys will complete it. It's very simple. All you need to do is just to brush your integration skill. So if you integrate it very well, you have z equals to 0 to 5. You have 4z plus 8. Plus z plus 8. Remember, when you integrate this one, you have x squared. When you substitute 4 here, what do you have? Making 60 divided by 2, 8. You have 8 here. So when you integrate this one, what do you have? Please go and find out the z. So now so the entire this place, when you integrate them, the entire displace. When you integrate it, you will have something 4x at the 4z at the end of the day. So go and find out how to do that. It's a simple thing. These are the things you've done in your part 2 in your calculus. Okay. While we proceed, we have this. We have integral of, sorry. If you integrate this one, what do you have, please? Anybody? You have 4 z squared over 2 plus 8z 0 to 5. So when you integrate 0 to 5, what do you have? Substitute the value, please. You have 4 into 5 squared over 2 plus 8 over. At the end of the day, you have 90. Any question?
Hello, sir.
Go ahead.
Which one did you just integrate now? I didn't quite get that.
Z. You know, you have two things. You have to integrate with respect to this. When you integrate with respect to x, that was what I said, go and find out. But when you integrate it very well, you have this. Let me use that. You have this one. You integrate and substitute upper limit and lower limits. You will have it. You will left with 4z plus 8. And integrate 4z plus 8 with respect to z. What do you have? You have this. Then when you integrate it, you know it has the lower limit and upper limit. Substitute it. Then you have 90. Any question? Yes, I'm listening. Silence means no question. Okay, let's proceed. Let's look at another example, but
4 times 5 is 20. 20 times 2 is 40. Okay.
What do you have? Is it not 90?
Yes, sir. It's 90, sir.
So I don't expect you to ask any problem with that, because I know naturally you know that one. So any question on that?
I don't. No, sir. No.
So let's solve another question. Evaluate. Let me just solve one more in this case. Evaluate. Integral x f dot the x, where f is equals to z over x squared exponential x squared and S is the surface described by x squared plus y squared equals to 16 for 0 less or equals to z less or equals to 3. With the x oriented outward. Oriented outward. So how do we solve this problem? What do we mean by this? Please, what comes to your mind when you see this question? Anybody? Yes? Please, I want you guys to talk. If you don't know anything, just tell me, oh, I don't know what will come. Or should I be calling your name?
Okay. I don't know it, sir.
Okay, only one person don't know. It's okay. Let's wait for others.
Same here, sir.
What is the meaning of same here?
I don't know. Don't know it, sir.
Oyedele,
So I don't even have idea. I don't have idea of it, sir. I'm just looking.
you are just looking. Don't just look. Oh. If you are just looking, then there's a problem somewhere.
Eh,
Will you just be looking on that day?
so I'm paying attention to know what is wrong.
Okay. Because I can see all of you are just looking. You are right. Do you still remember your mathematics when they call about revolution, full revolutions? Probably I should digress a bit so that all of us will be on the same page. Do you remember when they said you have a 2 pi, you have when you have 0 to 2 pi, what is pi? Talking about 160 degree, 360 degree, 180. Do you still remember?
A little bit, sir.
When you have x squared plus y squared equals to r squared, talking about circle.
Yes, sir.
We still remember that?
Uh, 22 all over 7, sir. Yes, sir.
You
Yes,
still
sir.
remember?
22 all over 7, sir.
Which one
Yes,
is 2
sir.
over 7?
22 all over 7, sir. It's
Okay,
fine, sir.
22 all over 7. Okay.
Yes, yes, sir.
Do you still remember that one?
Yes, sir.
Yes, sir.
Okay. Do you still remember when you have, let me just keep this one first so that all of us can be on the same page. When you have x squared plus y squared equals to r squared. Who can still remember that? What does this equation mean to you?
Pythagoras theory, sir.
That says what?
that the hypotenuse squared is equal to opposite squared plus adjacent squared, sir, of a
Do we use
triangle.
it when it comes to circle?
This circle theorem.
This is circle what? Circle theorem. A squared plus B squared plus C squared. A equals to C squared. That's annotated. That's what you are talking about.
Pythagoras theorem.
Pythagoras theorem. I'm just thinking how I can go down to the grassroots so that I will not be, because I can see where I'm operating is a bit high.
Yes, sir.
Yes, sir. Oh, so you know it's a bit high.
Yes, sir.
Looking at the question, how many of us have seen this before? How many of us have seen it before?
You mean the question?
Yes.
I've not seen it though.
Have you checked your past question very well? Have you checked your past question? So we'll move on to volume integral and share my screen again. So we'll come back to the surface. So let's look at the volume. Under the volume integral, when you see V, when you see this, it said F equals to X, Y, Z squared. Now said find the volume of F dV. So, but in this case now, we have a kind of this Y and Z. Then here we have 0. So this moves to this side. Then we have this. So in this case, we have 0 here. Here, so we have 1. We have 1. Then here we have 3. We have X and Y. So what does it mean? We need to look for so for us to solve this, we need to first of all resolve what we have here to be able to cater for X, Y, and Z. For us to get the limits, in this case, we need to calculate this. So the limit in this case will be, according to the angles we have and the triangles we have, y is equals to, what is y? You can say y equals to 1 minus x. Then s is equals to 1 minus y. Do you all agree with this? Hello?
Yes, sir.
Do we agree with this?
Yes, sir.
Yes, sir. Yes, sir.
Okay, how do you agree? Tell me. You can explain. You said
If you
yes.
look at the diagram, sir,
Okay, go ahead. Thank you.
if you look at the diagram, y is carrying 1 and x is carrying 1. So to get y from the point of from where they emanate from, you see that y is equal to 1 minus x. Yx is 1 minus y, sir.
Okay.
Sorry, sir.
Okay.
Does it mean that the coordinates of x and one of them is 1, sir?
Yeah, that is the question I'm trying to ask you, but you've not answered it. You are still throwing the question back to me. What is the coordinate in this case? How does it appear to you? Let's talk. Tell us.
Okay, sir. Thanks, sir. What I noticed on the line that you just did 3D line, sir, is that I noticed that there's 101. Then the y equals to 1 minus x. It appears is like a equation of a straight line, like y is equals to mx plus c. So um that's actually um how much I can I was able to actually bring out from here. Like that's the equation of this line
Line integral.
underneath.
Okay. But is
Yes, sir.
this answer correct or not? Is y equals to 1 minus x correct?
Yes, sir.
Okay. That's where I'm going. So you're right. The both of you are right, but the angle you are using to explain it is different. So the concept means you can look at the equation of straight line. You can look at you can see how many triangles you have there. You can see different things you have that are involved in this case. But now that I have this, I can calculate y squared. I can say y squared is equal to what? If I want to
Square root of 1 minus x.
no, I can just say x. Sorry, I can calculate my. Okay, what is my z in this case?
Z will be taken as
So you agree with me that we have at the end of the day. Okay, let's just leave it this way. Let's leave it this way, and let's continue. I will explain along the line. We'll come back to this integration. So the integral we have here is volume integral that says x, y, z squared, the x, the y, the z. It simply means you are going to integrate the x first, the y follow, and the z follow. So it's going to be integral of z, integral of y, then so I'm going to have, let me ask from here, let's say z squared dz, integral of y dy, integral of x will be 0 to 1 minus y, the x is x. So I will keep this one constant and integrate this one. So it's going to be z squared dz, y dy. So for me to integrate this, what do I have? X squared into 0 to 1 minus y. So if I have x squared into this 1 minus y, I can actually substitute upper limit minus lower limit. You remember? Are we there?
Yes, sir. Yes, sir.
Let me take my 1/2 out. I can say 1/2 is outside here. I can integrate this one, z squared dz, y dy, and here I have 1 minus y all squared. Because I know that if I substitute 0 here, I will still get the 0, so I don't need to bother myself. Then the next thing to do is what? Who can tell us? I'm waiting, please.
Okay.
Can you open the bracket of y, 1 minus y? What do you have? 1
minus y minus y plus y squared.
plus y squared, right? So you have y squared minus 2y minus y plus y, right? Plus 1. Do you agree with me?
Yes, sir.
Okay. So where do we put it?
We put it in the bracket, the square bracket, sir.
In the square bracket. Then what happened to y? Y dy, what happened to it?
We integrate the y squared minus 2y plus 1. That will be the second integration.
Okay. After that, so now let me explain. We have 1 over 2 integral of z squared dz. Now, in this case now, for us to get the limit of this, you have it to be zero to 1. Substitute everything here back to this place to replace this. What do you have? What do we have? Agree with me that this particular function is already in form of y. So we are going to have y in bracket y squared minus 2y plus 1 dy. So all we need to do is 1 all over 2 integral of z squared dz. Now let me open this bracket. What do I have? 0 to 1. I have here y cubed minus 2y squared plus y dy. So I can now go ahead and integrate this. So I'm going to have, remember, because as we are moving on, you are not doing it like line integral. You're still going to have single answer. This is not the x, y, z. So it's going to be integral of z squared dz. So for us to integrate this one, I have y4 over 4 minus 2y cubed over 3 plus y squared over 2, 0 to 1. So if I substitute the value here now, remember, anytime you are working, you will be getting value. If you are not getting value, you get related alphabet that or variables that we are working on. So it's going to be z squared dz. So let's solve this one. I have 1 over 4 minus 2 into 1. So plus 1 squared over 2. If you substitute 0 there, everything will turn to 0. So you don't need to bother yourself. If you calculate this one very well, you are going to have You have 1 all over 2 integral of z square dz multiplied by 1 all over 12. So at the end of the day, you have 1 all over 24 integral of z square dz. Any question? Now, remember from that, yes, any question? Remember from our diagram, the value for z in this case.
Sir,
Yes.
is it 1 over 12 or 1 over 24, sir?
It's 1 over 12, but remember when you take 12 out, you have 1 over 2 outside before.
Yes, sir.
Then 12 times 2,
Okay, true.
24. Then
Yes,
from the diagram, go back to the diagram, you have 0 to 3. That's the limit for that. From here, you have 0 to 3 for z. So what we do is the lower limit for z will be 0, the upper limit for z will be 3. So we go back to the drawing equation. So we have 0 to 3. Then let's integrate it. When you integrate this, you have 1 over 24 in brackets z cubed over 3 into 0 to 3. So I will have at the end of the day 1 over 24 in brackets 3 raised to power 3 over 3. So at the end of the day, what do we have? 3 times 3 times 3 times 3 is what?
27.
27.
27.
27 over 3 will be what? 1 over 24 multiplied by 9. Am I right?
Yes.
So at the end of the day, you have 3 over 8. You have 3 over 8. So what it means is I just splitted the integral. On a normal day, all the integrals supposed to be going together. I just splitted it so that you can understand. It's still the same thing. The 3 integral still be the same thing. Let's look at this example. Let's quickly look at this example. Because of our time, I have another class. Let's 5 equals to 4, 5 x squared y, and let V denote closed region bounded by the plane bounded by the plane bounded by the planes. Therefore, x plus 2y plus z equals to 8, x equals to 0, y equals to 0, z equals to 0. The question says evaluate the integral. Evaluate the integral. And don't forget, let V is talking about what? Value. So remember, you are to find the limits from this bounded area they gave us. Then let's look at the solution. In this solution, we have integral V by dv. So then how do we solve it?
Okay, sir. We'll look for the partial derivative of the phi, sir. That for 45x squared y. Then after I've done that, we now integrate it by part.
Okay. To get what? To get what, please? Shola? Go ahead. To get what?
I said we'll first we'll do a partial derivative of 45x squared y. Just as you have taught us now, sir. Then we'll now integrate by as you have integrated by part. The outer, the middle,
diagram
and
to explain yourself. Are you getting it now? So we have our x here, we have our y here, we have origin, and here is z. So this is moving toward this plane. While this also moves toward this plane. And this is moving towards this plane. So the question is, just have the pictures of what you are asked to do. Then you will succeed. So in this case now, remember we need those limits. First of all, the keeping x and y constant. If we keep x and y constant, what happened to this? We now integrate from z equals to 0 to, now how do we make z here? Remember this equation, we'll be working towards, remember we have x is 0, y is 0, z is 0. That is the origin. Are you getting the point? That is the lower point. That's the lower bound. Then for us to get the upper bound, we use the equation to get the upper bound in this type of question before we start integration. You don't need to differentiate anything in this case. So you agree with me if I said z equals to 8 minus 4x minus 2y. Do you agree with me?
yes.
Please don't say yes when you don't understand. Say yes because you know. Do you agree with me now, everybody?
Yes, sir.
Just make z subject of formula here. That is what happened.
Yes, sir.
Okay. Now, we have 1. We need to go to x. We need x. We can still say that in this case, we said s constant and integrate with respect to y. So that is xy plane if S is constant, so our Z in this case is equal to 0. Then what happened here? We now said Y equals to 0 to what will happen to the other Y? Who can tell us other Y? If you know what I did in the first one, what is Y now?
I don't get it, sir.
Okay. You agree with me that wait now, we are coming. You agree with me that Z is equal to 0 from the question?
Yes.
Now, if Z is equal to 0 from the question, and we now take, so remember that we have integral that we are working on. We have it in three integral. Let's say x, y, z. Z is equal to 0. To what? To 8 minus 4x. Are you getting it? Minus 2y. That is it. Do you agree with this?
Yes, sir.
Now, why now we keep x constant in xy plane, and we are looking for y, and z is equal to 0. What is going to be second? What is going to be upper y? That is my question from that equation that I gave you.
Y is going to be equal to 8 minus 4s minus z all over 2.
Z all over 2. Z is 0 now.
No, that is 8 minus 4x minus z all over 2 from the equation.
8 minus 4x.
Okay, when you now divide it, what do you have with 2?
8 plus 4x
equals to y.
That will be 4 minus 4 plus 2x.
Is it 4 plus or 4 minus?
It's 4 minus.
Thank you. So our second y will be 4 minus 2x. Do you all agree?
Yes, sir.
Yes, sir.
If it's not clear to you, tell me. Just say it's not clear. I will explain. Silence means it's clear. Okay.
Sir,
Yes.
I don't understand how you come through with the y.
So you agree with us that we have 4x plus 2y plus z equals to 8.
Yes, from the question.
From the question. And
Yes,
you
sir.
know that the lower bound is y equals to 0.
Yes.
They now said, look, if y equals to 0, they now said, okay, let's look for upper bound. We are given this equation to get y. And z is equal to 0. Why you are trying to get y? What happened?
The first one, you make y, you make z the subject of the formula. Remember, you have 8 minus
Now
4x
make y
minus
subject of
2y.
formula here.
Okay.
And make your z to be 0 inside it.
Okay.
So you have
That will be
4x
4x minus 2.
4x, wait to plus 2y equals to 8. Then you now have it to be 2y equals to 8 minus what? 4x. Do you agree? Hello?
Yes, sir.
Okay. Divide both sides
Yes,
by
sir.
2. When you divide both sides by 2, what do you have?
4 minus 2x.
So that is how we did it. Can we proceed now?
Yes, sir.
Aha. Welcome to 300 level or 400 level. Or what level are you guys?
300, sir.
300, sir.
Oh, okay. So now let's look at, we now we are going to Z plane now. ZY plane. ZY plane. What is going to be the X? We know X is equals to 0. What's the upper X?
Yes, so the formula again.
Is what? Somebody is saying something now.
I think he said we should make X the solve formula from that equation.
Remember, in this case, Z, you only need, yes, the first equation. Remember, Y and Z will be 0. S is equals to 2. Am I right? Okay. All of you, you are your own.
Sir, we're trying to catch up with your speed, sir. Yes, sir.
Is it 2 or not? You guys, am I running? I'm not.
S is equal to 2.
S is equals to 2 now. Okay,
Yes,
you
sir.
have, look at it. 4x plus 2y plus z equals to 8. They said this one is 0, 0. Right? You have 4x equals to 8. Divide it by 4. S is equals to 2. That's all.
Yes, sir. Thank you, sir.
Do we all agree?
Yes, sir.
Yes, sir.
Okay, now
Yes, sir.
we can now go
Yes,
ahead
sir.
and integrate. Now we have the limits. So when you are given this question that day, look at it very well. Make sure you are able to get the limit before you start it. So that let's move to the question now. We now want to solve it. So for us to solve this, we have it to be, let me say x is z, x equals to 0 to 2. Second one, y equals to 0 to 4 minus 2x. The third one, z equals to 0 to 8 minus 4x minus 2y. So our file is what? 45x squared y dz. Remember, I arrange it according to what I want to substitute. The z is the first one, followed by the y, and followed by the x. Who can tell us why do we do it this way? Just a simple point. Remember that the last one has ordinary digits. It doesn't have any variable x, y, z. So it's easier for me to evaluate. If you substitute the one with a 0 and 2 first, then you are in trouble. What will happen to the rest? And you must get values. Do you get the point now? So let's solve it. Integral of x equals to 0 to 2. Then integral of y equals to 0 to 4 minus 2x. So for us to solve this one, I can take my 45 out. I can say x squared y we still have z here too. Please check, do we have z? No. So we can now integrate with z. If you integrate with z, you only have z here. Do you agree with me? Hello?
Yes, sir.
When you integrate the x, what do you have? You have x.
X.
That is what you have. So in this case, now there is no others will be constant. We just owe them, but integrate the z alone. You have z from 0 to 8 minus 4x minus 2y. So I can substitute it now. So I now have 45 integral 0 to 2 integral 0 to 4 minus 2x x squared y in brackets 8 minus 4x minus 2y dy dx. So we can also consider by saying 45 integral of 0 to 2 integral 0 to 4 minus 2x. Don't drop it if you know you cannot handle to drop. Just write your y equals to 0 so that you know it's for y. If I open this bracket, I will have 8x squared y minus 4x cubed y minus 2x squared y squared dy dx. So can we solve this one? Can we see you integrate this? Please, everybody start integrate the y. Let me see.
Okay, sir.
So if you look at it, to integrate this one is simple. Now, anything you want to integrate now, you are integrating with respect to y. Don't forget. Integrate with respect to y. So we have 8x squared y squared over 2 minus 4x cubed y squared over 2 minus 2x squared y cubed over 3. The limit 0 to 4 minus 2x dx. How many of us got the same thing?
I got it, but in a more simplified way, I had to divided the 2 by 8, then
Of
the
course,
4 by
you
2.
do that. So you have it to be 45 integral of 0 to 2. Here 1, here 4. Here 1, here 2. So you have 4x squared y squared minus 2x cubed y squared minus 2 over 3 x squared y cubed. Everything dx. So you can see it's simple for us now to integrate the same thing. 45. Let's integrate with respect to x now. You have 4x cubed y squared over 3 minus 2x4 y squared over 4 minus 2x3 y cubed 3 times 3, 9.
The X.
The s, where do you see the s again?
No, not yes. I'm trying to follow up with something. Yes.
Oh, okay. So you can factorize, you can do whatever you like. But at the end of the day, what do you have? Anybody? Let's all use our calculator now. Punch with your calculator, substitute 2 or 2. But don't forget, we still have y here. How do we do that? Recall that y is equals to 4 minus 2x. So, which implies that 45 in brackets 4x cubed, your y squared now returns to 4 minus 2x. You remember squared over 3 minus 2x to the power 4 into 4 minus 2x cubed square rather over 4 minus 2 over 9 into 2 over 9 x cubed 4 minus 2x over 3. Everything from 0 to 2. I believe you should be able to compute this. So if you compute it very well, anybody please? Any answer? No answer? You are going to get 128. Any question, please? I hope you are hello. I hope you understand how to compute this. Hello?
Yes, sir. We substitute the upper limit. That's x. Make s substitute 2, which is the upper limit to the value of x.
Now, please, let's do it. I want to confirm something because on a normal day here, this is where I'm supposed to substitute y equals to 4 minus 2x at this point before I integrate it. But let's test something, whether it will work like this or not. Let's try it together, please. Just bring out your calculator if you have one. We have 45 here. Let's see whether it will work. If not, we will change it. 4 over 3. We know that in the 4 over 3 here, we have 2 raised to power 3 into 4 minus 4. Oh, okay. You can see where it will not work. Yeah. Because this will be 4. minus 1 all over 2. Let's see. This will not work too. All the answer will be 0. Do you agree with me?
Yes, sir.
Everything will be 0.
Yes, sir.
0,
So
sir.
it will not work here.
Yes, sir.
Let's just substitute it. Sorry to disturb you guys. So in this case now, what will happen is we substitute first. Let's substitute first before we solve it. We have 45, right? And 45 is still 45. But let's look at it. What is common here? Something is common.
2x squared, sir. 2x squared y squared. 2x squared y squared, sir.
Okay. Okay. Now I see. We did not substitute our value. So let's just substitute first. 4x squared in bracket. What is y squared here? It's supposed to
4
be what?
minus 2x squared. 4 minus 2x squared.
4 minus 2x. 4 minus 2x all
4 minus
squared.
2x.
Minus 2x cubed. You remember now?
Yes, sir.
4 minus 2x all squared. Minus 2 over 3 x squared. 4 minus 2x all cubed. So this is the limit we failed to substitute because I remember y is equal to 4 minus x, and we did not do it here. So for 45, we have, now let's now look at the common elements. Or let's see the one we can add together. Which one we can add together? Look at it very well.
We can add 4x squared, 4x squared in bracket 4 minus 2 all squared minus 2 over 3x squared, open bracket 4 minus 2, close bracket 3 square of 3. So the 4x squared minus 2 over 3 squared, they are of the same term. They have common terms, sir.
Are you sure?
So I think we should go for 4x squared, open bracket 4 minus 2x squared, minus 2x cubed, open bracket 4 minus 2x squared.
Okay, that's another suggestion. Look at it very well. What do you think we should consider here? Is it 4x squared we should consider, or 4x minus 2x all squared we should consider? Anyway, anyone you want to consider, all you need to do is, I will leave it for you to do it. How? I will explain the way you will do it, and you will do it now before, because I have to join another class. All you need to do is expand this one, 4x minus 2x. Expand this, expand this. Once you expand this, you automatically expand this one. You can factorize one out of this and substitute it. because you need to integrate first before you substitute the limit. I hope I'm clear.
Sir.
Hello?
Yes, sir. Yes, sir.
You need to, if you look at it, you need to integrate first before you can substitute it. So go and open the bracket. Okay, how do you open this bracket now? 4x, 4 minus 2x is what? Hello?
16 minus 16x plus 4x squared.
4 times 4, 16. Minus 8x minus 8x plus 4x squared. So you have the answer to be 4x squared minus 16x plus 16. Are we together? So you don't need to even disturb yourself. Now you have this, substitute it here and here. Then how do we get this one? In 3 places. You can use one of it to multiply this one now. Right? Hello?
Yes, sir.
Use one of it to multiply the square. Then anything you get, put it here, then integrate it, substitute the value. You must arrive at 128. If you do, let me see, once you finish this particular part, send it to me personally on the platform. Thank you, guys. Any question?
Thank you, sir.
You're always welcome.